Welcome back. Today we join a craftsman as he raises an off-grid cabin from the ground up, fighting the shifting seasons to secure a permanent shelter before winter sets in. Establishing a foundation on uneven forest terrain relies on sinking vertical posts below the frost line. This anchors the entire structure against seasonal ground heave. Squaring the perimeter with string lines ensures the future structural loads will transfer evenly. Heavy timber horizontal beams lock the isolated vertical supports into a single rigid base. The tightly spaced grid of floor joists provides the essential span strength required for a living space. Setting these precisely prevents floor sag over decades of use. Working from beneath, he secures the primary layer of the subfloor. Driving screws upward, tightly compresses the wooden sheathing against the joists. This underside layer acts as a vital barrier against ground moisture and drafts. It protects the insulation that will eventually fill these cavities. Moving above the joists, full sheets of plywood create a solid, continuous deck. Staggering the panel seams across the joist grid maximizes the shear strength of the floor. Nailing a perimeter board binds the edges, completing a stable working platform. With the wall frames built flat and raised into position, temporary bracing becomes critical. A long diagonal board resists shear forces that could rack the structure out of square. Until the exterior sheathing is applied, these tall walls are highly vulnerable to wind. A heavy tarp provides immediate protection against unpredictable forest weather. Water saturation on raw framing lumber can cause severe warping before the wood cures. Installing a double top plate ties the intersecting walls together at their weakest points. Overlapping the lumber at the corners creates a continuous load-bearing ring around the top of the cabin. This structural ring prevents the walls from bowing outward when the heavy roof load is applied. Every nail driven here ensures the downward compression remains perfectly plumb. The skeleton is now rigid. Oriented strand board locks the vertical studs into an immovable diaphragm. The cross-laminated wood flakes distribute impact and stress across the entire wall plane. Once fully sheathed, the structure transitions from a fragile frame into a true shelter. Setting the door frame requires careful shimming to maintain perfectly plumb sides. Even a fraction of an inch out of square will cause the door to bind permanently. Applying heavy roofing felt establishes the primary waterproof membrane over the roof decking. On the vertical walls, a continuous layer of synthetic house wrap manages moisture vapor. This fabric prevents liquid water from entering while allowing trapped internal condensation to escape. Overhead, ridged metal panels overlap to shed rain efficiently away from the vulnerable eaves. Tacking the house, wrapped tight around the rough openings, is a critical defense mechanism. Wind-driven rain naturally seeks out the gaps between the rough framing and the eventual siding. By folding and stapling the wrap deeply into the window cavity, the barrier remains unbroken. A properly sealed envelope drastically reduces heating costs in a cold climate. The cabin is now a dry capsule. Caulking the exterior frame blocks the primary infiltration paths. However, true weatherproofing relies on the layering of black flashing tape. This rubberized adhesive bonds directly to the window flange and the synthetic house wrap. Applying the tape from the bottom up ensures that water cascading down the wall sheds outward. It acts like architectural shingles, eliminating any reverse seams where moisture could pool. The tight tolerance preserves the integrity of the wall interior. Penetrating a finished roof introduces the highest risk of long-term leaks. The stainless steel chimney pipe must be isolated from the combustible wooden framing. A flexible silicone flashing cone conforms to the ridged profile of the metal roof. Securing this base with screws and a heavy bead of sealant creates a watertight compression fit. The double-walled pipe design keeps the exterior cool while venting extreme exhaust gases safely outside. Capping the top prevents downdrafts and animal intrusion. Thick fiberglass bats trap pockets of dead air within the wall cavities. This slows thermal transfer, keeping the interior heat from bleeding into the freezing forest. Friction holds the fiberglass tightly in place between the studs. Overhead, tongue and groove wooden planks lock together to form a solid, draft-proof ceiling. The wood adds thermal mass to the room. As winter sets in, the cast iron wood stove becomes the heart of the shelter. With the fire radiating intense warmth, interior finishing can proceed comfortably despite the snow outside. Applying joint compound over the drywall seams creates a continuous, unbroken surface. Feathering the edges smoothly hides the structural transitions and prepares the walls for paint. The mud cures rapidly in the dry, heated air. A simple metal gutter system captures the immense volume of roof runoff. Harvesting rainwater is a critical component of off-grid self-sufficiency. The massive holding tank requires a dedicated, reinforced platform to support the extreme weight. Water weighs over 8 pounds per gallon, making ground stability paramount. Routing the downspout directly into the lid directs the entire roof's yield into the reserve. A flexible hose connection easily absorbs thermal expansion and minor settling. The closed system provides reliable utility. A deep green exterior paint seals the porous siding against UV degradation and moisture. It visually anchors the structure into the surrounding tree line. What began as a bare clearing in the snow is now a formidable self-contained refuge. Every hidden fastener, layered membrane, and precisely cut timber works in concert against the elements. The landscape and the structure now operate as one resilient system. It is built to endure.